today I will be making some foot rails for a local doctor's office. So a lot of the employees are in the office have taller desks with like bar height chairs, stools with backs on them. And so their legs dangle and they don't have anywhere to put their feet. So I was reached out to by a nice gentleman named David, owns the office. And so he's contracting me to build a bunch of metal foot rails to go underneath all the desks at this doctor's office, mount to the wall and or the floor, and have a 12-foot tall bar for the employees to rest their feet on. So this is what I'm gonna use. This is, I believe, 2-inch Schedule 40 steel pipe. I think the OD is a little under 2 inches. OD, of course, being outer diameter. It's right at 2. So that's perfect. I think this will be a great size. It was reasonably affordable. And so I have, I think, 5 straight pieces to make and then 1 angle. So 5 of these are gonna be straight on the wall and then 1 of them is going to be in a corner. Kind of, you know, the 45, the hypotenuse, if you will, of the triangle in the corner. Which means that corner piece will have angled ends. It doesn't have to, but I probably will do that. So I'll be making brackets to hold the bars off the wall and the floor on the Shop Saver plasma cutter. I'm just gonna design something cool based on those like brass foot rails you see in bars and stuff like that. I'm gonna design something similar that I can weld onto the pipes. And then when we get them blasted, powder coated, finished, and get them to location, the brackets will already be in place and all I have to do is drill into the wall and or floor. Probably just wall and have a felt pad on the floor. Either use a drywall anchor or find a stud. I'm just gonna plan on drywall anchors because I doubt I'm gonna be able to find a stud. So I'll have to figure out how many brackets I wanna have per bar, like if I wanna have one every 2 feet or something like that. I think the beginning of this build is gonna start in the office, designing a bracket and double checking all my measurements and cuts and figuring out really what to design. So how about that? This is the 2-inch Schedule 40 in question. As you can see, it gets delivered with a nice damaged end. All the ends are like that, but it's only the end. It gets better once you get down the pipe a little bit. So this is what we'll be using. I bought 2 of these. I've got my other saw set up on this table because that saw over there, there's not enough room to the left of it. It's a part of my shop that I need to retool is the bandsaw cutting to length portion of the shop. But between this and a portaband, I'm not making that many cuts, so this will work. But I'm gonna go back into the office and do some thinking. All right, well, in the interest of actually doing something today, I'm gonna clean the dust off the rails here of the machine, get it zeroed in, put some 1/4-inch plate on there, get it set up to cut, and cut me a test bracket to see how it fits. Yeah, let's do that. All right, so I've got a piece of 1/4-inch on the table right now. I'm gonna go ahead and try to cut out some samples. That's not 1/4, that's 3/16. 3/16 would honestly be fine. It's just a matter of what I've got. Let's see, I've got 1/4 here. That's a pretty big sheet of 3/16. Bet you I can get a lot of brackets out of there. 3/16, here's a big sheet of 1/4. Here's a 3/16 circle I could cut some out of. I'm gonna vote we switch gears and do 3/16. Yeah. All right, just decided. So this is good. I just gotta change the 85 amp consumable in here to the 65, which is what was in there. I was a bit naive with how big the brackets are. I can't get anything out of there, so I'm gonna swap material and put a bigger sheet on. All right, you've seen it a million times, but here we go. We're gonna zero our torch. Got the program set right. Got the hypertherm turned down to 65. All right, here we go, hit go. See how this looks. All right, that's interesting. I've been having this issue where it's not detecting the plate very well, but I will like clean this and problem gets solved. So what I'm gonna go do right now is go through all these electrical connections, make sure this is good, clean all this and make sure, I don't know, it's been happening gradually over time. So for it to know that it's making contact, this has to conduct to the steel, then relay the signal to this, which relays a signal to that spade connector, this guy, which relays a signal to this plug, and then all the way back through. So there's quite a few areas where circuit separation can occur. That's clean. All right, let's try this again. Hey! Well, that looks wrong, doesn't it? That's wrong. Boy, today is not my day. I'm gonna wash my hands, have a coffee, sit back down at the desk and see what I up. Okay, so I figured out what I did on that bracket. This circle is twice as big as it should be. So this needs to be 1.9 inches diameter. The circle I drew was 1.9 inches in radius, so twice. Diameter would have been, 2.8 something. 2.8. So now you can see the difference. Hey, 3D modeling for the win. Now, what do we think of that? How does that make you feel? While Walker sits over there and complains about Adobe, I will update you on where we're at on these bar foot rails. I should have screen capped this, but I didn't. So I will film my screen with the camera. Laying out some more parts for these foot bar rail brackets. Can't talk. Bar foot rail brackets. It's less wrong. Let's send this. I don't have much 3/16 material, which is why it's oddly shaped, but we'll send this batch to the cutter and see how they come out, check them against the pipe, and then I think this is gonna do it. So we might even tack one together just to see, and then we can go into full speed production mode.
Wood.
This is why you get the big bucks. All right, well, we got more parts in the plate ready to cut. This is almost all the brackets. I don't know how many I need. I haven't gotten that far. I'm just cutting them out as I find pieces of 3/16 to go. I got other scraps I can use, but I think after this, I cut all these parts out. I'm gonna clean them, prep them, and then cut all the tubes to length. And then I'll figure out how often I want to bracket on each tube and how all that's gonna work. Plan. All right, so I got all the straight sections cut. Now I gotta cut the 42-inch long, 45-degree piece. So I'm just gonna set the miter on the back of the saw to 45 degrees, cut one end, measure and cut the other end, and there you go. And then I will cut discs in the plasma cutter that I can insert in here and TIG weld in so I can plug all these holes. And then the rails will be done. Finish cutting the rest of the brackets, use the fixture table to set up a fixture so that I can weld the brackets to the poles, and yeah, we'll be good. Making good progress. Okay, today's goal is to finish these foot rails because next week I need to switch. It's Friday. Next week I need to switch to something else and get that done. So, let's hit it. Well, you can't see that, but I've measured the holes, and so I'm going to cut some plugs that I can weld in with the TIG welder. So let's go do that. I won't bore you with the drawing. I'll just cut to the cutting. This is why I love having a plasma cutter, because you can just make stuff that fits perfect. So now I'm gonna weld these plugs in, and then the bars are done, and then it's bracket time. Bracket time. Also, I got new glasses with side protectors. Prescription safeties. How about that? All right, so pretty much welding all this with fusion, which means I'm just using the TIG torch to melt the metal together without adding filler. Looks pretty good. I think it's gonna be just fine for what I'm trying to do. And it's pretty fast. I got a pulse setting over there, 1.2 pulses a second at 150 amps. So here we go. I'm just gonna breeze through these. Alright, so making a jig can be as an exact a science as you want it to be. I'm kind of going somewhere in the middle. I'm using my slotted angles, my 5/8 6-inch spacer block, some inserter clamps, and some vice grips, basically. But anyway, so I gave a little pocket for this tab to live in. This guy just falls into place here, and then I clamp that there, and then it holds this foot here, and I know that everything is square to itself because the table and this square are, well, square. So I think it'll work. I'm not doing a million of these, so I think this jig will hold up long enough for me to do what I need to do. And I'm just gonna MIG weld all this because it's all getting blasted and powder coated. All right, I'm gonna tack this one, pull it out of the jig, see how it looks, maybe hold it up against the corner of a wall, and then crank them out. All right, I'd say this system's working quite well. Coming out very consistent. There's gonna be minor differences, but for what it is, it's not gonna matter. So now it's time to calculate how many I need for all the tubes, cut all my extra parts, finish making these, and then weld them together, and then we're ready to take them to the blaster and powder coater over there at CNC Fab. So I thought you guys might find this interesting. I found some more 3/16, but it's a circle. So what I'm doing is I drew all my parts in a square, this is a 28-inch circle. So in the software, I drew a 28-inch square and then drew a circle inside that square and then positioned all my parts inside that circle. So theoretically, once I establish a nice 0 point, I should be able to cut all these out accurately. We'll see if it works. I'm squaring this framing square to the side of my table, and then nesting the circle in the square, which means because this machine usually zeroes off of a corner of a square plate, this point inside this framing square is now my origin, 0, 0. So I'll zero the torch here. Because I did the same thing with the circle by zeroing it in this corner of the square in the software, I should be able to accurately cut all my parts out of this circle. So let's see if it works. That worked perfectly. So while that was cutting, I went ahead and made a file for this so that I can achieve the same thing. And that was all my parts. I needed 9 more, and I got 6 and 3. So I needed 6 and 3, yeah, exactly. Beautiful. I literally had 0 more 3/16 plate in the shop. So I squeezed all my parts out of a weird looking rectangle and 2 leftover circles. See, that is why you save your drops. While the camera was dumping footage, I mocked one up. Looky, looky. I wanted to test this on the corner of a wall. Before I proceed, there was no reason this shouldn't work, but I just wanted to see it.
Look at that.
How cool is that, huh? So those tabs will obviously get screwed into the wall and they'll be felt on the bottom of these feet. The whole thing's gonna get sandblasted and powder coated. But I'm quite pleased with that. It's heavy duty. Those brass foot rails that are on the bars, they're pretty scrawny. That's all to do. How about that? Just got to make some more. So while the camera was dumping footage, I cranked out all the other brackets, and I made a backboard here with some flat bar, and you'll see how I lay these out in a little bit. But this one is almost done. Just gotta weld it up. Three down, 3 to go. I'm quite pleased with how these are coming out. I think they're going to be super sturdy and look the part as well. It is 5 o'clock on a Friday. Going to finish up these 3 on Monday and then take them over to CNC Fab and get them blasted, powder coated, and install them at the customer's location. Okay, so all the straights are done, and now I need to do the 45 bar. So I'm gonna retool the table a little bit, and I'm gonna utilize 2 of the edges, I think, to simulate the corner that the bar is gonna go in. And then I'll find a way to sort of mock up the brackets, one this way, suspend the bar in the middle, and weld everything on. I don't think it's gonna be that much harder. I'm just gonna kind of clean some things off of this side of the table and mock it up. All right, so here's the setup. I'm using the corner of the table, as I said, to simulate the corner of the wall. And I've got these 2 pieces of tubing clamped on either side, either face. This piece of tubing is supporting the leg, as you can see. And then this piece of tubing lets me know where this tube is gonna sit in relation to the wall when it's all said and done. So I just guessed on these 20-inch dimensions for the legs. I didn't want to get too close to here. I definitely wanted a gap here in between. So we got about an inch gap in between the wall the way it is. If I wanted to close that gap, I could move these brackets in some this way. But I also don't want them to be too close together in the middle for aesthetic purposes. So I believe this is going to strike a pretty good balance. So I'm just gonna weld it up, and then I might just go test fit it in the corner of my office or something just to see how it feels. But I think that's gonna work. Let's send it. So I found a spot over here in the bathroom where I have 2 open corners, and I will show you what it looks like. Look at that. So I think that works rather well. I'm sure there's a million ways you can put a foot rail in the corner, but I think that looks quite good, and it matches the aesthetics of the rest of them. So I'm going to weld it up, and then we are done. We are ready to take them over to CNC Fab to get them blasted and powder coated. A cool bronze color, might I add. And then we set up installation with the customer. So, yeehaw. And it sits flat, so you know it's square. How about that? There are all the finished rails. Looking good. Okay, so we're here at CNC Fabricators again. Just dropped off the bar foot rails. They are sitting here, ready to get blasted and powder coated. They got a bronze powder that they're looking for right now. So that part's done, dropped off at the shop, and now we're heading back to Lift Arc. I'll come pick them, show you guys when they're done.